up everyone, welcome back to our channel Easy Math. Today in this video we'll continue the topics from the previous video, that is introduction to the sets. If you haven't checked out the introduction part, I'll leave a link below. Do check it out. So today we'll learn about the types of sets that we have. Now first today I'll start with the null set. Null set. A null set is defined as the set that is empty or the set which contains no elements. Such a set is called a null set, and the designation of a null set is given by the symbol phi. This denotes the symbol of null set. Now I'll give you an example for this. Suppose I have a set A. I'll write this set in roster form, or I'll just give an example in the set builder form. I'll give an example as x such that x is an element between the numbers 1 and 2. So we see that such a set does not exist. We do not have any elements between 1 and 2, but we do have the decimal places, but we do not consider them. We do not have any natural numbers between 1 and 2. So this set is a null set. A null set is also called an empty set. Now I'll move on to the next set, that is finite and infinite sets. So by the name we can just suggest that the sets that are finite are countable sets. First I'll give you the definition for finite sets. Finite sets, the sets in which the elements are countable or the elements have a limit. That means we can either count the elements or it has a limit. It just stops at a certain point. Now I'll give you a simple example for this. I'll take a set A as elements of the natural number, the first 5 natural numbers 1, 2, 3, 4, 5. Such a set is a countable set. We can count the number of elements in this. We can say that the number of elements in this set is 5. So this is a finite set. We'll move on to the next set, that is infinite set. The name itself suggests that the elements in this set will be uncountable or limitless. The most simple example for this is the set of whole numbers or a set of natural numbers. If we write the set builder form for this set A, we get the elements as 1, 2, 3, 4, 5, up to so on. It goes on till infinity. So this is the example for whole numbers, and now for the natural numbers. Now we'll go on to the whole numbers. Whole number starts from 0, 1, 2, 3, 4, 5, and this also goes to infinity. So such sets are called infinite sets. Moving on to the next set, we have the sets that is equal or equivalent sets. There is a slight difference between these two sets. It may look like equal and equivalent maybe look like same, but there is a slight difference. First we'll go to the equivalent sets. Equivalent sets are the sets in which the number of elements matter. It depends only on the number of elements. It does not depend upon the content of the elements. So I'll give you an example. Set A with the elements 1, 2, 3, 4, and a set B with the elements 1, 5, 8, and 9. We see that the number of elements in set A is 4 and the number of elements in set B is also 4. So we can denote it as set A is equivalent to set B. and this is the symbol for equivalence. Whenever the number of elements of both the sets are not equal, the equivalence does not apply here. So the next is equal sets. The equal sets focus on the number of elements as the equivalent sets, as well as the contents of the set. So I'll give you a simple example for this. Set A, we'll take the same example, 1, 2, 3, 4. This is a set A element of natural numbers, first 4 natural numbers, and they are 4 in number. And a set B as 4, 2, 1 and 3. The number of elements in this set is also 4. So we can see that the number of elements are 4, as well as the number as the content of the set, that is the elements are also same. We have 1, 2, 3 as well as 4. So we see that all the elements are same, that is the number of elements. It satisfies this condition as well as the contents of the set. It does not matter if whether the elements are arranged in proper sequence or not. We can say that set A is equal to set B. This is the symbol for equality. So we'll go to the next and the last final set, that is the universal set. The universal set is the biggest set of all the sets. All the sets belong to the universal set. That is, every set in this universe or the sets that exist belong to the universal set. The universal set is denoted by the symbol U or the symbol mu. To explain this concept of universal set, I'll draw a Venn diagram. What is a Venn diagram? That will be explained in the later topics. Venn diagram is represented by a rectangular box, which is the universal set U. In this set, as I said, that the universal set is the biggest set and all the sets come under universal set. This is the set of all the real numbers, this is the set of all the whole numbers, and this is the set of all the natural numbers. So we can say that in the universal set, all the other sets exist. So guys, this was about all the sets in the chapter of sets. All the types of sets we covered in the sets. Now in the next video, I'll cover the basic operations that happen that we use on the sets.
For more videos, guys, subscribe to our channel, and for further queries, comment in the section below. Thank you very much.